Hello everyone, welcome back. We're going to be doing some development on the Nexus Mods app today. First of all, yes, I did have an accident riding my bike a couple weeks ago, and so I'm still getting over the video I have up here is mirrored, so it's a little weird, pointing the wrong side of my face. But yeah, got a black eye, ended up in the ER, a couple other things, I'm fine, but that's why I look like I got beat up a bit. So today we're working on an ORM. Essentially, we wrote a kind of a custom database for the Nexus Mods app, and it works fine. But what we're wanting to do is get some better data access patterns into this. Let's start some music here too, goodness. And so what we're writing is kind of a system where we can write our models like this. Where is I have it in our test here. So we have these models, right? So we can define a mod that has a string attribute on it called name, a URL attribute called source. It references a loadout, so the mod points to the loadout, which is here. The loadout has a name. Files point to the mods, and so on and so forth. So what I'm doing now is going through our tests. This is the test we're working on here, where we create a mod and add a loadout and commit it, and then do some checks against it to make sure that it all worked. Now, the problem we have right now is if we look here, this is the data is coming out, we've lost this. So on the right side here, this is what the past tests have output, and then this is what the current test output. So we've lost this pointer to the loadout. So first of all, let me get a chat window up here so I can actually see if anyone says anything. There we go. We'll put that up there. Cool. Yeah, and so one of the things that we're doing here, so this database is modeled after some database called Datomic, as well as DataScript, and there's some other clones of Datomic. Datomic kind of pioneered this, but it's a tuple store. All of our data is in the format of an entity ID, an attribute, which is actually itself stored as an integer, and then we have a value. So in this case, we know we have entity 1 has a name of test mod. The source is test.com. And we have a loadout here that is, it should be pointing to the loadout, but it's not. We've lost this tuple. So we're just going to go through, first of all, I mean, I know where the problem is here. So once we analyze our entire, our input, so source generators allow you to analyze some code and then emit more code. And that's what we've done here. So if we look at here's our, let's look at the generated code for the mod. So the generated code for the mod here, when we actually go to emit it into the transaction, we're emitting name and source, which we see here, but we're not emitting the link to the loadout. So we need to do that as well. And so that's in our model template here, in the add to method. So here, add to, we're only going over the attributes. We're not as well going over, we're not also going over the references to other models. So this may work if we just give it a name like this. I don't think this will work for more complex models. Let's look at the mod here. So in the mod, in our add to, we should now have name, source, loadout ID. And if I go to our tests and run those, we'll see that no, we still don't have the loadout. Do we need to reload that? We have a different, why is that a difference then? Oh, because we have an error in the code here. So this is loadout, not loadout ID. So one of the things I've done by convention in this is to references get ID appended to the end of them. So we just need to update that. And then rebuild. We should see that reflected here after this reloads. There we go, loadout ID. And then if we run this, so now we get an error still. Well, not an error, it's just failing for some reason. We are still not getting that received. That's really odd. Because we should be calling the in on the add to. So we can debug this. So let's see here. On this commit is where it's going to actually execute that. So we can dive into this. So when we commit a transaction, we look to see if there's any temporary entities on the transaction, which is what these are. We should have two temporary entities, which we do. We have the mod, which has a loadout ID and a name, and the source is test.mod. Why is this not printing out? I wish it was printed out with a toString, but whatever. Okay. So what's the first entity we get is the mod. So let's step into this. Now this is still loading the old version of the add to. It's like this somehow hasn't figured out that the source code has changed. It's like it's cached somehow. Let's clean it and build it. I have had this problem some. Oh, okay, it's not building because the compilation's failing. That's weird. I wish the tests actually failed to load. That would be nice if they completely failed, if like it wouldn't even run the test if it couldn't compile. Okay, so let's see here. Attributes does not contain a definition for mod ID. And this is in, oh yeah, because this is in the collection. So we have reference and references. So we do have two types, and I guess we'll break this up again. because MnemonicDB also has a multi-cardinality attributes. And multi-cardinality is like, and just saying, instead of saying like you have one name, you could have multiple names. This is useful for something like a tag, right? Like a tag on a blog post or something like that. You wouldn't want to create an entire list of entities. You can just say, hey, this thing has a list of strings. It's actually a set, but that makes sense. So let's see. If it's multi-cardinality, we want to admit. We'll come back later and fix that because that is actually wrong. There we go. And the formatting for these T4 templates gets a little wacky. That's, by the way, what we're using here for our templating is T4 templates. They are included as part of C#. It's pretty easy to use. Okay, so if it's multi-cardinality, we want IDs on the end of both of these. If it's not multi-cardinality, we just want ID. And then if we go here and look at our collections, oh, we had an error in that template. We expected a, oh yeah, because we need, there we go, 2 type arguments. Okay, well, we'll see that in a second here. So in our collections here, okay, so we do have a problem that, okay, so this expects multiple IDs. Is that what we call it? We call it IDs instead of loadout ID. What is the name of this loadout ID? Is this just loadout? Oh, interesting. That's wrong. So this name should actually be loadout singular and not loadout. Well, it has a name of referencing nothing. So I'm not sure why that actually worked, but I guess it's referring to one of these over here. We should change that. So first of all, let's go back to that template and change how we refer to those in the attribute definition. So here is our multi-cardinality. We don't want to use name of because this name wouldn't match. We just want the name itself. And then the same here. So what we should find is if we go back to our collection, that this should update so that this will say mod and loadout, which it does. Okay, so the mod IDs. So the difference here is that this is like the internal database name is mod, and this is in the software side, the C# side of it is mod IDs, because these are IDs. It's not a mod itself, it's a reference to it. So we're referring to it as that. Now down here, the problem is that this transaction doesn't really have a way of taking multiple IDs. Now we could update it to do that. So mod IDs is a references attribute. So we could add that to the transaction, and maybe that's the better route here. iTransaction. So we have add for a attribute. Now let's also do void add entity ID, and the attribute is a references attribute, and then the value is an IEnumerable of entity ID. IDs. So adds datums for adding the given IDs to the transaction under the given attribute. Cool. So then this will then fail because we need to update our transaction concrete type to support this. And this is pretty simple. We're just going to do, well, we don't have to do the committed check on that. I guess that doesn't hurt. Okay, so then for each one of the datums, we're going to add them just like that. That works. Now we'll fail here because we have an internal transaction in the system that doesn't support this. Throw new not supported exception. We don't need this behavior here. And okay, cool. Now, if we go back to our collection, we will see that this now passes because we're inserting all of that. And now it looks like the test model compiled. So now, yes, in fact, we do get the new, we can look at we need to reload this. How do we reload it in here? Close other tabs. Let's try this. This isn't reloading for some reason. We're seeing it here down in the actual test. So the problem here in the test is if we see this doesn't match up, right? 5, 6, and 7 is instead of B, C, and D. When I wrote this model, I redid how some of the attributes work. And so the IDs have shifted around a little bit. We're using a really nice feature for unit testing here called verify, which allows us to do data comparisons like this. So we can compare two lists of datums. So we'll just accept that new value. Now this is saying it still doesn't work because we're getting in 4, 5, and 6 now, or 5, 6, and 7. Oh, that's right. This one is this test is a little weird because we generate a bunch of files and they are changing, but okay, we're just gonna kill that. We have to keep accepting on all of these because they it is advancing slowly. There we go. So now it actually passes. Because if we look at this test, what we're doing is we have like a for loop and we call verify table in this loop. So we're kind of making changes and make sure that each change matches up. Okay, so 2 tests pass now. We have our changes and make sure that we don't have any unverified. Okay, that works. We'll commit and we can see here our diff. So we moved from 5, 6, 7 to B, C, D. Cool. And then we'll commit this to our branch, and then we'll move on to the next test. I like to do this sometimes, just comment out all the tests that are broken so that I can focus on one test and passing that. So what we're doing in general here is that it shifts from file.model, that's the old version where models were a nested class underneath, and it's now just file with a transaction. And then here we, instead of getting the model from the DB, we say file.get original DB and real ID. So it's a static method on the model that you're trying to get. And then this returns a read-only model. So we can't do like found name. That doesn't work because found is only has getters on these attributes. So that's nice. Okay, so we get the model and then we need to verify the model. We need another one of these probably. Settings task. Model. I don't know that we actually need this T value. Do we actually use that anywhere? I guess we use it here. Yeah, okay. Enumerable of I read datum. And then this is just verify table model. Cool. So we just need to work on some of these getters here. So this is attributes. So attributes are now, what we did is that the attributes used to be on the main class, so it was like file.path, and then the model was file.model, and it was nested in that way. We flipped that around so that the attributes are now on the top level class, are in their own class called attributes, file attributes path, and then all of the getters and stuff are on the base level. So same sort of thing here, file.get, file.get, new DB, wow, goodness. New DB real ID. And the same thing here. Cool. And then this test is data immutable? Cool. So this fails as well. Oh, because we have a completely new format. The old tests would print out the entities in this way, and I'm doing it differently in this sort of method now, where we have this table format. So it's just to verify test 1 plus dead beef, 1 byte, and then a mod ID from, yeah, that works. So we accept the received file. Oh, and then because this is a test about the immutability, we got to make sure this path here changes. So that's correct. This is the original. And then mutated data 1. I'm just making sure the actual values here carry over, which they do. Test DID, you're correct. And then, yep. Again, correct. Cool. Now, if we reload this here, we'll see that, oh yeah, we get all of these different files that show all the changes that we have here. So we'll save that. Cool. And the next test. Don't know why this got indented. So there we go. So this deals with an archive file. And I don't necessarily want to dive into this now, but maybe we should. So what we need to support archive file. So archive file is something that I implemented on this code originally. That, let's see here. Models. Well, let's just rough out what this looks like. Model definition. So archive file is to show that we can have like two attributes of the same name, and we can do inheritance and stuff like that. So we do archive file. And what we want is an attribute on this called path, a relative path attribute, and we're going to call this path. And then we have like a hash attribute called hash. Now, the key thing here is that the like these collide, right? This path and this path collides, and this hash collides. But what we're going to do is also say, I don't know if we want includes, composes, we can just say includes file. And then we want .build. So this is the pattern that we want, that we're like, hey, an archive file is a file, and we're also providing these extra attributes onto it, right? So I guess we can start in on this. So first of all, the way the source generator stuff works is that this model definition that we're building is just a class that does nothing. So this attribute method that we see here is just this. It takes some arguments and returns itself. So when we say includes, what we're going to do is go up here. Well, we have composes here originally, but I don't know that I really like that. So instead, public static model definition includes a T model. And we're just going to return this. And what we want to say is where T type. Do we actually have? We don't have any restrictions on this right now. Interesting. We'll have to see about adding some restrictions to that model class later. Oh, that's a static. We don't want static. So by that, this model includes another model. Okay. So we're going to include that. So if we go back to our models here, we see this now works, right? The archive file includes the file. Now I imagine if we build this, we're going to be, it will actually build, but we're not going to get really what we want out of this, which is, let's see here. There should be one here for archive file. Let's maybe debug this and see if we get an error. So we're debugging the source generator now. So what source generators are like DLLs. They're like little plugins into the C# compiler itself. So let's look at in our source generator, we have this method, let's see here, model generator. So we'll put a breakpoint here. So now we're actually debugging the compiler itself. So we're handed some syntax. We actually have 5 chains of calls. So it should be, let's see, methods. This is, the new here is arguments. So that's file. So that means this one should be archive file. It is archive file. So we have this call to include. Let's see. So 1, 2, 3. This should be file. This is archive file. So we get the concrete model for archive file. Let's see what this has. This has 2 attributes, path and hash. So what we haven't done is updated this yet to, we need another method on this concrete model called includes, and we'll get to that. Well, actually, let me get to that now. So what we're doing here is this whole nasty bit of code right here is basically looping over our code and looking for invocations of something called .build on model definition. And then what it's doing is taking the type arguments and the method name and the arguments for all of this and putting them together into a chain. And then we analyze that chain. So if we look here, if we debug this source generator, what we'll see, oh, there's our archive file. But if we go down here to chains, what we see is the our methods being called are new attribute build, right? That matches what we saw earlier. If we go here, methods, new attribute build, that sort of thing. New attribute reference build. So where's our one that's include new attribute build reference, new attribute build. I shouldn't have the include here. That's interesting. And that might be, So here's our archive file though. So we do have path and hash, but the problem we'll see is if we build our entire solution, the tests here, well, we can do attributes, right? So this actually works. We can add the extra attributes. We want to use this format in a second for building the model out, but we got to get the including working first. But what we're testing here is that we can do like db.get. Actually, this test may pass. So file.get db real ID, and then this is the same sort of thing with archive file, right? So this works, and this will probably pass. But what we're wanting to do is actually have, like, what we can't do is when we get this model down here, archive model dot, we don't have size, for instance. So we're setting the size here on the file, and this archive file doesn't have a size. So we've kind of just mashed 2 models together. They are technically composed. And we could do this in another way as well. New archive file, and we can give it an ID of file.id, right? And then we do path equals whatever this value is. So this also works. And would probably give us the same effect. But what we're basically doing is saying like, hey, here's a new archive file. We're going to reuse the same ID, and we're kind of overlaying them on top of each other. Just for a test, let's actually like see how this works. This is read model can have extra attributes. Read model can have extra attributes. Here we go. So if we run this, what we should see is that we didn't register that model. So let's do that first. Add test model, add archive files model. There we go. We got to register that in the DI container. And then what we see is, you know, we've gone from the old format. Well, okay, this is interesting because the old format just showed file as a file, right? And now we actually have two clashing attribute names. We have path and path. Now they aren't technically clashing because they are namespaced and they are separate instances. So this is the file path and this is the archive path. And we see like test.txt versus test.zip. And we use this in the app a fair amount. Like it's pretty important that attribute names are namespace. So like if someone else comes along and adds another hash to the same entity as you, it doesn't just clobber your data. They can have their hash, you can have yours. So we're going to go ahead and accept that and then do it again. And we see that like, oh, before we had archive path and hash and then path and size. And now it's the same data returned. So we can go ahead and accept this again. And that works. Now, the problem here is that, I mean, this works. There's nothing technically wrong with this, but this is like ad hoc composition. There's nothing that says in our code that the archive file has to be a file, right? And if we were to swap these around, it would work just fine, even though we still want this to be inherited. There's no C# level inheritance, so let's fix that. Let's go to our let's see, method chain. No, not the method chain, the concrete model. So we have case include, maybe just singular include. Let's go to our the builder. What is that called? Model definition. So if we go to our model definition, I think I would rather have include. All of our stuff is kind of singular here, like new attribute reference. References is when it has multiple attributes. So we're going to do include. And then in this method chain, when we're analyzing it, we can say if it's include, then let's see. Concrete mod, we need a new class, a new record. So this is going to include a, let's see, public type info. So it's going to include a, I'm going to make sure this has an init. Oh, that's right, we can't use inits. So what the code, the subset we're allowed to use here is slightly less than like C# whatever 8.9 or whatever. There's a couple features that aren't supported. So all right, so let's do model dot, we want to add a slot on here. So public list includes. So these are all the included models that are part of this. So var include. So let's do var include equals method generic types. So we're going to get the first generic type, and that's the one that we include. And we'll make sure that's not null. What's the problem here? Cannot I type, oh, it's not type info, it's I type symbol. the include by type symbol. Cool. So we have this type symbol now. And so now we can do that and break. So now we've included that includes as part of our concrete model definition. So now if we go back to our, let's see here, to the model generator, what we should find is that here, oh, we don't need the chain name, interesting. So when we go here and debug this, we'll see that we should get one of these called, oh, this should be include. So our, oh wait, no, we want to go down to the other. So our concrete model for the first one is mod, and then we have file, and then we should have archive file. And this has have an include, it does not have an includes. Interestingly enough. So this walks through all the different methods and finds them where let's make sure we actually are, because I didn't see it in the method chain earlier for this, so let's make sure this is working. So the type we're building here, yeah. So I think we want to wait until our current invocation here. The current invocation is file and then archive file. Okay, so we got the archive file. And this should be the build method. And let's see. The current invocation is now, so we'll see here on this, like if we do current invocation, we'll see that we're like in a chain of methods. So we're all the way down at attribute. So we do have include there. So now we'll run again to here. And if we rerun that current invocation, we're kind of walking up the chain of methods because it is a tree. And we'll see that now we are at, what is this property? Just so we have attribute. So the next one should be include. And let's see, the last one at this chain is in fact include, right? So, we're jumping over this because the method definition symbol containing type. There's something different about our include definition versus the others. So let's see, include. Public include T model. Okay. Let's try this again. So we go here. So the current method, a current invocation is mod. Now this should be file. And then this should be archive file. Okay. And then current invocation is attribute. So we did 2 more, and then we're at include. 1, 2. And then we do this again. And what we should see is that we are at include. Okay. So let's look at what the symbol is. Symbol is null. So current invocation is this. Semantic model.get current get symbol info for current invocation. And what is this that we're getting at this point? This is symbol info. Overload resolution failure. Interesting. What's the semantic model here? Is this because we don't have a... Well, let's try this. Let's go to our include. And let's add an argument. This is the only place where we're doing this and we don't have an argument. Right? So find usages here. So now if we run this, one, two. Now when we're here, the current invocation is build, still build, hash, or the attribute path. Now we're at test. No, it's still. I wonder if something's being cached here. I know the source generators cache some information. I'm wondering if that's part of the issue here. Are we getting any errors as far as in our generation source generator? Looks like we did get one warning when this ran. Oh, should specify the enforce. Yeah, so our project should specify this. We'll do that real quick. They want to have this like strict mode on in the system, so we'll do that. Oh, current cultural info is banned for... Oh, really? Well, I'm not actually calling that. So I guess the T4 templates are not happy with this. Great. We may have to redo that template, what we use for our templates there. Okay, so let's look at this again, though. What is going on as far as 1, 2. So here's the, if we look at our invoking with, this is a file. And then this is the archive file, right? Yep. So build attribute, attribute. So this is include. So what do we know? We know that it does load up the source correctly because we're getting the correct source here. So it's not a caching issue that way, but our symbol info is null. Okay, so I guess the next thing I would ask then is what happens if we go to our model definition and we rename this to foo. And then we go to our models. Oh, is it because it might be because it's having a problem resolving to it may be have a problem resolving. Okay, that could be. It may be that it has to run multiple times because it's failing. So let's do this. Let's go up here and we're going to output our includes. For each var include in includes. And then we're just going to output here. Let's see here, models. Okay, so we're going to do archive. So model.include. That's right, concrete model. It's called includes. So for everything the model.include, we're just going to output include.type. Info. So if we run this a couple times, do we see it show up in collections? We should see something up here. So let's see. I think the problem is that it's failing to resolve. Let's see here. Let's look up source generator partial output signaling. Let's see, partial. No, that's not what I'm looking for. Because what we're kind of trying to say is that we don't want to output this model yet because it refers to other models. So let's see. I guess the question would be, so in this model definition, then why does this not work when the other things did, right? Because we do have some references here. Let's see, clean solution. So if we look at our source generators here for archive file, we're still not getting anything up here in this top part as far as like the attributes coming out. So the includes is an interesting problem. It should exist though. So we're going to take this out because I don't think it's that we have an argument here. It's just actually saying that like the model that it gets doesn't exist yet. And it can't resolve that symbol. Let's see, source generator. Hashing. Incremental source generator. So let's look at what we got here. So I'm reading up is that, okay, an source generator, simple example, implementation pipeline. Multi-valued providers. Select many. This is not what I'm looking for. Many to many. Okay, so we're getting all of our use cases. So let's do this. Let's go to our analysis here. And we're going to put a condition on this. Symbol null. And we're just going to stop the moment we get a null symbol. Build invocation. Okay, we're just going to do this. Okay, so the symbol we have here is null. The current invocation is include file. Now it's interesting, the symbol info that we have here is, I think, the include, right? So like, what if we instead say like, okay, what do we cast this to? This is casting model definition symbol. So symbol is just null. So the semantic. So what is current invocation? Our current invocation is a invocation expression. So our build invocation is a, so this is like the lowest level parent is a invocation expression syntax. And this is also invocation expression syntax. So what if we try to get some generic methods? Well, this is a as method symbol. So the method name here is, yeah, we gotta have the symbol to get all this. So let's look up this error. If we do semantic model dot get symbol info of current invocation, what do we get? Overload resolution failure. So what is a overload resolution failure? Let's open that up. C# overload resolution failure. Force generator. Afraid this isn't too exciting today. Okay, so if it is an overload resolution failure, maybe changing the name. That's what we were gonna do before. We're just gonna name this foofar, and then we're gonna run this and see what we get. And we have an error here. So the current invocation here is that. So we just can't resolve that for some reason. We can't resolve the call to this. So if we say references, though, that'll be a question. Does references work for if it has a reference to file with the name of foofar? Does this, in fact, come up also with an error? Because that would tell us that it's a type. It does. And what we're currently looking at that's failing is this reference, right? And if we take this out, Mm-hmm. So if it references a file, like that doesn't work. So let's look at this then. What's the difference between how this is defined here? So we have this mod defined first. And that works to define the loadout, right? Now, all the references are down at the end. Does that matter? It's just the archive that's having the issue. Do we have an exception in this code or something? Nope. All right, well, I'm going to think about this one a bit. I thought this was good. We were going to get a little farther on this code today. I mean, I guess we can keep working on this a bit because this test does pass. We'll just have to look at combining them. So I guess we can get all the rest of the tests working and then come back and fix this stuff for the archive file. Let's do that. Just so we're not sitting here twiddling our thumbs trying to figure this out. And I'll go on a walk a bit later and see about figuring out this. Cool. So here we're going to see if we can get commit updates. And so let's see. Here's the test for commit updates. I expect the same sort of errors here of it not matching completely. 399 for hash. Yeah, I just went from 355 to 399 is the attribute names shifted around a bit, or the values. It's not a semantic difference. 9955. Nine and 55. That is correct. One 6. So here's an interesting difference. What's the difference here? Oh yeah, 9 and that correct. And same thing, 9 and 5. Cool, that passes. 2 more tests. All right. Commit that. Okay, can get child entities. Oh, this is going to be a fun one because we're going to have to dive into the models as well on this because child entities aren't technically supported here yet. So we have loadout model, and then we have mod model. And ID must be set, is what it's saying, the mod and the ID. Yep. And then we commit that, and then we remap the loadout. So our remap function needs to be fixed. Remap function currently takes I has entity and ID and DB, which we don't want. We just I has entity ID. That's all we need for that because we're supplying the database as part of the remap function. Okay, so Now we get to implement child entities. And this is going to be a bit fun because we're going to get to do some pluralization. So here's what we have right now is on our loadout, we have an attribute named name. And then we technically need a back reference to this. So what we're going to want is back ref to model, to mod, I mean. And this is going to be called, I guess, mods, plural. So we don't need to do pluralization. We can do this just like this. Now, the question is if this works, because the other one didn't work. So I don't know if this would either. Let's see if we get this error. Don't seem to. Let's go to our concrete. Well, we'll code up the template and then and go from there. So let's see, a method chain. In the case that we get a back ref. So back ref is, I'll show you here. In our example here, the mod points to the loadout. So now we're going to find a back ref to the mod. Oh, we actually need two names for this. We need a name that specifies the mod name, which is going to be, the mod name is going to be mods, loadout. And then our local name is going to be mods. Right? So string other attribute string this attribute. So what it says here is that this is the mod.loadout. So mod points to us via the loadout attribute, and we're saying we want to find all the mods that point to us, the backwards reference, right? So we won't do convention on this. We'll just have loadout and mods is how we're going to name this. And then what we're going to do is we need to code that up. So we have a type argument and we have two other arguments. Let's go to our concrete model and public record back ref. I type symbol, and this is going to be other model, public string other attribute name, and then public string this attribute name. And then in our that method chain, it's this thing here, we're going to do this and then do var back ref equals new back ref, and the type other model is going to be method.generic types 0, and then other attribute name, and then this attribute name is going to be that, and then we need another collection on our concrete model for that. So now we do model backrefs, add backref, and break. Cool. So now we should, in the loadout, when we're building this, have access to all the back references. And let's code that up. We can first of all create just a very simple, let's see here, this is in the template. So this is going to be on our read-only model. And class read-only. do we define the actual class here? Okay, read model. Cool. So we have our attributes that are listed out on the read model. And then we also need for each model.backref. Let's see here. So model.backref, backref. So for each one of these backrefs, we're going to go and output some code. And that's going to be public. Yeah, that's actually fine for now. But instead of this, we're going to throw new non-implemented exception. So not model name. This is going to be the other model. Model name. And this is just going to be to display string. We got to make sure all these types are properly namespaced, or we're going to end up other not an attribute name, other model name. There we go. And then backref dot this attribute name. So if we do this, I would expect, well, we'll get an error until we actually go down here and do this and close off that for loop. So I would expect to see, oh, this remap for T. Commit result is not, we gotta match this up. We broke this earlier. Has entity ID. Oh, get and then this will break because DB needs get. Oh, interesting. This remap function is not correct, is it? In this commit result here, in this remap, we need to like throw new not implement exception. We don't actually want to use that anymore, I don't think. We got to find a better way of solving that. So some of the code in this system had like we used to hand code a lot of this, and so some of it's kind of optimized around having the least amount of hand coding, and we're moving to this model where we're generating a whole lot of the code, and so I'm not so worried about some, you know, reducing the character count in the models because they're going to be generated for us. Okay, so now if we go to this loadout thing here, do we see read model? We don't see it here. Do we see an error? Let's see, source generator, it's complaining about that. So let's debug our source generator. Now, if we're really having a problem with how we reference the different names here, then, no, there we go. Okay, it did work. It just, the source generator hadn't run yet. Okay, cool. So we have this non-implemented exception. Good. So what we see now is that if we go back to our test, this one here, Okay, so this remap is not returning a read-only model. So this is the old format where we have this loadout and then we say remap and we return a new loadout, but we actually need to change the type. So first of all, what I want to do is change this to like loadout equals loadout.remap result. Right, we want to change it till we do this so that this remap can return a read-only. Well, interesting. We won't actually be able to do that because the type here is a new entity that we just created, and then we're going to end up assigning that to a read-only entity, which is going to mean the types don't match up. I mean, not that that can really be helped. It's just, I liked this before, but we don't really have a way, and it wouldn't work with this method either. Like, we're actually trying to define a clear model around this. So on the temp entities, what we need is a remap function. So let's add that. So let's see here. And actually, I'm starting to wonder if we couldn't base a lot of this off of a base class that we pass in our types to. And I think it's something that I'm going to look at here. Is that right now we look at this loadout, we base everything off of iTemporary entity, which is just a interface. But if we took a little bit of time and passed in, we could pass in like loadout and read-only loadout or something, we might be able to make some of these like put it in a class so we don't have to duplicate the code. But for now, we can do it this way. So we have our constructors, and then we do public. We're going to return a model name, model.name of read only, or is it read model? And then remap. And this is going to take a abstractions I commit result. So on our temporary entity, yeah, let's see, and then remap. So we have this result, and we want to remap the ID. So now if we run this, what we should see in our loadout here is that we have this thing here, loadout read model. Now that doesn't work for some reason. Cannot resolve symbol loadout read model. Oh, Roddle, goodness. It's model, not Roddle. Okay. So after this reloads, we should see that that links up. And what this then does is allow us to remap from this, which is a temporary loadout entity, and it allows us to remap into the other format. Now, so we see here, cannot convert type because, you know, the types don't align, but that's fine. So now we have loadout written .mods. So I'm actually liking how this is shaping up. Formalizing these models means that we can't actually use these in the wrong way. There's a lot of foot guns in our old approach where you're kind of like, it was all hand coded and stuff. So as we see here, like this models thing only exists on the read-only model, because when you're building these entities, there's not really a good definition of who points to you. It's kind of just all a temporary amorphous data that you're constructing. Once it's in the database, then you have mods as a attribute on the written model, and you can access them and get the values out of them. So now we get the first mod. Now this one doesn't have a loadout reference to the loadout, so we do need that. So let's go to our models, and the mod Oh, the mod has a reference. The mod has mod ID. So like this works. It has ID, right? First mod. Oh, you know what? I think we might have the same problem here. Does mod have a reference to the... It does. Read-only model of... The mod's read-only model does not... Oh, we didn't add the references in on the read-only model. So, oh, just the back references is what we had, right? Right, okay. So let's go back to our template here. And we will just grab this code here. And then we'll go to where we have the back references. And in the middle of that, we will insert our references. And this will return static. What is the reference that we have here? Oh, no, not static. So it's just public entity ID with the name. Oh, if it's multi-cardinality, it's a IEnumerable of entity ID. And then otherwise, it is just an entity ID. And then to get that, we want to do this. Mm-hmm. Reference.name, IDs, boom. So once we do this and compile this, let's look at what our mod code has then. So when this loads, okay, we have some errors here. We got some formatting problems. Why is that indented so far? Oh, because it is indented so far. Okay. And then, what's the next thing? Oh, yeah. The entity ID needs to be prefixed by abstractions. So there's a problem when writing code that writes code like this, and you run into this a lot in like Lisps and stuff, is that you can have namespace clobbering, where like if you define loadout ID or entity ID and I define it, then we could have a problem of, you know, where the names collide. Mispronounced abstractions there. So I'm prefixing all of the namespaces with these, like, you can see it at the top here, we're doing either like models, abstractions, or DI, right? So, okay, so we still have an error here because it's not loadout ID. Here, it's attributes that loadout ID, and then IDs. Cool. And this should work. Let's see. Yeah, that does. I mean, it doesn't solve the problem, but we're down to the next step here. So actually, here we go. So we do have loadout ID. So this would work. Right? We can do that. Or what we really want here is also we want a set of getters that gets the actual read-only model for that as well. So we'll start with the single cardinality and say public IEnumerable of It's an IEnumerable of reference.other model name. Is that right? Yeah, that kind of might be right here. Dot reference model. Let's give ourselves some helper functions here. So reference model is this, attribute name is that. Let's do public, because we normally would have to call like to display name on this. So string reference model name, and this is gonna be that. Cool. So now we can do reference.reference model name, read model, yep. And then we're gonna call this name. So this would just be on the singular case, it's just a loadout, right, which works. And then, yeah, I don't know what that code generated did. What we really want to do is like throw new not implemented exception for now. And we'll look at the output of this for the mod. And what this says down here is like loadout. So, oh, in the case of a single loadout, we don't want that. We want, this is a scalar model, not a whole list of them. So we're gonna do that. So this is just a single read-only model. Read model, yeah, there we go, cool. So now that we have that, what we're gonna do is implement this. Which actually is just as simple as this code here. So we do new reference model name, and we pass it loadout ID and the database. I think that's all it is. And when this generates, yeah, that works. So when we get the loadout, we're gonna new up a new loadout model. And then when we go to our tests here, we can see that we can just do loadout.id.value to make sure that works. So what these tests are doing, is just making sure that we can traverse between the different entities. So we've created this like graph of entities, and we're walking through it to make sure that it all works. Now, who knows that if this will actually work? But let's see if we can get child entities here. It's not Canadian. What's the problem here? Oh, the IEnumerable. What? This is, wait a minute. So the first mod is a read-only model for the mod, and loadout is one thing. So what it's complaining about is that, okay, IEnumerable of loadout read model does not contain a definition for ID. It's like saying that this loadout here is a collection, which it's not. What? I think this really is a problem with those source generators being stale. I'm still figuring out what's causing this to happen. Because like they're not stale here in the IDE, but the types just don't. There we go. See, like now we get a completely different thing, which is like method or operation not implemented. So going from the mods, okay, so the back ref, right? So now we've gone to the back ref, right? So now what we're at here is like loadout.written.mods. So this here is not implemented. And this gets to be a little tricky. So what we actually want, so the nice thing about the database that we have here is that we have these references, and the references are backwards indexed as well. So what we can do is if we go to IDB, find, let's see, references, get reverse. So given an entity ID and an attribute, you can get, I mean, you're basically getting everything that points to you through that attribute. Which this would allow us to get all the mods that point to a specific entity. And internally, that's really just calling datums. Let's see here. Get reverse. And this is just calling a get. Yeah. So this is really what we want to access here, but we don't want to get, So I've swapped this model over where like this specific get reverse here is newing up some entities, and we don't really want to do that anymore. So we could take that out and just say like whoever's calling us needs to be responsible to manage the entities. That would be fine. We can also go lower level and access this at like the index level, which is not a terrible idea. But I also do think we want to look at, let's see here, some base classes for this. So like right now, oh, this does inherit from read-only model. That would be a rather clean place to put it. So we can do like public IEnumerable of entity ID, get back refs of through a specific attribute. We could say it has to be a reference attribute. Yeah, that works. So the doc string is here is like get all references for this entity that are through the given attribute. Yeah, so what we want is like DB get we just want this essentially, although we really kind of want the ID on this side because it's entity attribute value, and in this case the entity that we're looking up that points to us is essentially the value, right? So we want to get the back refs, and then we would do like for each well, actually we can just return this. That back refs can just be a set of entity IDs. So if we add this to IDB, and then we go to our DB here, what do we prefer the return type of this to be? So we have these entities, this entity thing, which is a struct. It's a really lightweight interface for referring to a set of entities. But that's not really what we want. What we really want is the underlying one, which is values, I think. So if we say this is a values, low level type, high level type, right? So entity ID of view long. And then our input is an attribute. Oh, I'm modifying the wrong method here. Let's see here. So what we really want is values of entity ID and ulong. And the reason we want this is because we can get an index segment. What is the reverse cache here? Is it? Oh, that just gets in this index segment. Nice. Okay, so the way this works is that we can call our backend and say, hey, get us basically a section of the database, an index, a bunch of tuples. And these come back as this raw block of memory, which is also like an IEnumerable of datums, essentially. But what we do is we put that into an index segment, and then here in our get backref, the output of this get is in fact an index segment, and we just need to return the struct that wraps around it and kind of gives it some context to it. So this is saying we can't create a, what is our constructor for this? Index segment int, oh, the attribute. We got to put the attribute on it too. There we go. So this is complaining, okay. IDB, we need to change the return type here to values of entity ID and ulong. So this is all now like really lightweight. It's cached. If we call this get backrefs a whole bunch of times, it's going to be pretty fast. And this values thing itself is just a really light wrapper that lives on the stack around that cache section of the index. It's all the back references for this entity that are through the given attribute. That works. So now if we go down to our read-only model, we almost don't need this, because instead what we can do is go to our model, our template itself, where we have this backref. And instead of throwing here, we can just give it a getter. All right, and then we say, well, that's not letting me type that in. So 1, 2, 3, 4. There we go. I think that's actually right. The formatting is so weird with this templating stuff. Like T4 templates are a bit of a pain to format at times, which makes me think that maybe I need to find a different templating language for this. It wouldn't take much to transfer it over to something else. Okay, but let's see what it looks like here. When we run this, we get a ton of errors, but let's see what our model, let's see here. No, it's the loadout. So we don't need that arrow. anymore. And when this reloads, yeah, so we need to change that up. And this is not mod.get, it's read-only model dot. No, that's get, right? What are we missing here? Oh, the mod IDs is not defined. So we need to go to here and do db.get backref. And then we need the attribute name, which is actually other attribute name. And it's actually also backref.otherModel.attributes. ID. So we're going to find everybody that's pointing to us. Okay. So that resolves. And get back refs, plural. Okay. So one of the problems with using templating languages with source generators is that the compiler itself is pretty restrictive about the code that you can run inside it. The C# compiler is. It has to be .NET Standard 2.1 and, you know, older version of C# probably, and some other stuff like that. So it just gets a little, you know, a bit of an issue at times. Finding a template engine that supports all that can be a bit tricky. Okay, so now what we see is that in fact that compiles. And if we run this, let's see here, in our tests that we were looking at. Oh yeah, it was just not implemented, and that was the problem. So entity, whatever, does not have attribute mod name. So it is getting two mods here. So let's debug this. So loadout written.mods. It does have two mods. Loadout written.mods.first. Okay, so we're going to look at the contents of this mod. And we are in fact getting the loadout. Oh, right. So we don't want the... Yeah, the problem is there that we looked up the back references and then grabbed the values for all of those instead of the entity IDs. So this implementation is wrong. We're doing values here, and in fact, this should be like, this should be something else. Where is this class at? This is in index segments, abstract, in index segments. We have entity IDs. That's actually what we want, right? Yeah. So let's go back to DB, and this is actually entity IDs. And with it, we don't pass that an attribute. And we don't actually pass it any types either. Segment start end. Oh yeah, and then this is let's see here. IDB. So this is just a really clean way of wrapping our index segments up in kind of a flyweight object. Cool. Okay, so we haven't remapped some of these. That was the problem there, was that we had used a temporary ID, hadn't mapped it to a new ID. Boom, that works. So now we can traverse around the different entities in the graph and that sort of thing as well. And it's pretty cool. I mean, I'm going to probably end the stream here pretty soon, but I just wanted to kind of point this out. It works pretty well. Like, we create a transaction, we add a loadout to it. This is how we assign it to the transaction. We create a new loadout with the transaction set when we create the entity. We create two mods, with also added the transaction. We can say they point to the loadout, and then we commit it. After this point, it's in the database. But what we have here, the ID that's assigned to the loadout up here is a temporary ID, so we have to resolve that. So we get the new database. We remap the ID, or the entire object, actually the entity, to a new entity. So we can see the type changes from a loadout to a loadout read model. And then we can walk through all of these and say, like, hey, we get the mods from it. We get the first mod, and then traverse around and make sure all the IDs work. And that all works as expected. It's pretty cool. Still need to figure out that include problem. It's really weird that this is working in other cases, but not that one. I'm not sure why. But I'll look at that, and probably need to find a new templating system. Because as it stands now, we can't turn on the advanced warnings in our source generator, which is kind of a big no-no when it comes to source generators. So this will be the next one we do. Fixing this up is simple enough. We can do, oh, actually we got to insert example data. That's the other thing. I commented this out earlier, but we can do this real quick. So we're going to start a transaction, create a new loadout, create a list of mods. For each new mod, we're going to set the loadout ID. We're going to do file, assign them to the mods. Boom. We add all that in. And then we need to remap result. So then what we're going to do here is each time we do update one of the mod names, so we get some changes in the database as well. So attributes. This mod name here needs to be remapped. So we'll do tx result and remap the mod.id. And then here we're just going to do loadout. That should work. And then this, wait a minute, this didn't return, this returned something before and it doesn't now? I don't know why the return value there didn't work. I'm gonna undo that. Oh, I know, I think I changed that so that it didn't return anything. I was trying to get it to compile properly, so we'll just do that. Boom. Cool, that works. So now if we go back here to our DB tests, and so we're going to have to, what I'm going to have to look at next here as well is how we filter and load things based on a filtered attribute. So what we're doing is we want to find all of the mods. So this is a generic find. So let's rewrite this to what we want it to look like, and then we'll think about it. Like mod dot. So there's a couple of ways we could do this. We could do find mod attributes name, right? We could do this. Oh, this is finding indexed, right? So what we're doing is we're finding all of the mods, first of all. So we would want like all. So we find all the mods, and then we get the name of each one. So we get the name. And then we're finding any mod. Like we really kind of want this to be like mod where name is this name. We could even. So we're like looking up all of the mods, then finding that mod by its name. And then we're just outputting some information about it, like mod.id. And then we're doing like this name, so mod.name. And then by find this sort of thing, right? So something like this. But I'm not exactly sure. Like, there's different ways we could write this specific thing, right? We can do like var result. We'll do a mod.where, like where name equals, right? Foo. But what if we want other operators for this, right? We could do b where name like eq. Or not EQs. Some we could do the lambda syntax. So C equals mod.where m.name. That's maybe a bit more common in C#. People would assume that's a linear scan, but actually we could implement that as a index lookup, and it'd be super fast, which is kind of cool. What else could we do here? We could also do this format. C equals mod dot name, or where dot name EQ m equals foo. It's a little weird. That's also weird. Yeah, so we're gonna even think about this. One of the things I don't really like about this approach here with the lambda syntax is that the lambda syntax it creates an expression. In fact, let me get a example window going here. There you go. So this is Sharp Lab. If you haven't seen it before, it's pretty cool. Basically allows you to do some, prototyping of C# code and take a look at stuff. So the way this this find thing is normally done is you have an expression, func, let's say string, and returns a bool, right? And what this does doesn't really matter. Throw new not implemented exception. So you would use this something like this. You would do where, and this is going to take a string equals foo, right? So what this is saying is that we're taking there's two ways to do this, right? One is you can just pass in a function like this, but then all you can actually do is call that function. And if we look at the C# code, what we're doing is creating an anonymous function statically and then passing that in to our method here. So it creates this class here, and then it passes a new instance of that in here to our function. So all we can really do here is actually just call it, right? Which means that if you want to use this as a database, you can't get what it's doing to the string. You can only just use it as a predicate. But if we were to do expression right here, then something else happens. It's kind of cool. It creates an expression of parameter S, and it creates a syntax tree. And it builds a tree of that syntax and hands it to us. So we technically could here deconstruct that and build a query out of it. This is how LINQ works, the whole link to SQL and that sort of stuff. But as you see, this does a fair amount of allocations. And I think if we were to, if we change this to do something else, like name, return. Oh, is name out on there? So we're just going to return the type. And this is going to return a type. So if this is all we're doing, none of this gets optimized. It's allocating arrays and stuff. And if we look at the, we can't look at the JIT from that. But there's a fair amount of work going on here. So I don't know, may not be worth it. The nice thing about the other formats is that they really are just super optimized. If we were to pass in, name EQ, if we do something like this, where the name equals string value, and then we're just where name EQ foo and value.getType. Let's see what this looks like when it's optimized, because it's pretty impressive. I mean, it's just let's look at the C# version. So the C# version it calls into this method, right? There's nothing extra being generated. And if we JIT this, what we see is that it's a single call. It's a call here, call here. It's just so much faster. So I don't know, that does lead me to think that maybe it would be good to do it that way. We might be able to build our own AST system or something that uses a bit of a more concise syntax. But we'll think about that. Anyway, it's been going for about almost 2 hours. So appreciate everybody stopping by. Got some good work done. Got some things to think about. Appreciate it. I would like to start streaming more often. Like I said, I got injured. I fell off my bike. My front tire exploded. So I didn't want to scare people for a bit. But I hope to do more of the streaming in the future. I'd like to get in the habit of streaming every day, but we'll see how that goes. So, and school's ending soon too, so I'll have my kids around more. I'm not sure how that'll go. I'll have to get some noise canceling going on this stream. But all right, everyone, thanks for watching. See you later.